Hello again. We're going to continue where we left off. Exercise 2, section 7.1. We're going to continue from the last video. So go ahead and try to evaluate these. You can do all of these with a calculator, but try to do it without a calculator if you can. But if you have to, go ahead and use a calculator. Pause, come back when you're ready, and we'll go through them together. Again, when you think of logs, you're looking for an exponent to which you need to raise 10 because there's no number here, so that means base 10 to get to that number. Again, I'll write what it means. Y equals log of x means the 10 is the base, and you could put a 10 here if you want. The y is the exponent, and x is the answer. So again, there's another 10 here for the base. So what exponent do I get this? I can set it equal to x, and I can say 10 to what exponent is 10 to the 6.7, and you can see x is just that 6.7. If you remember, square roots mean raised to the 1/2, so that would be like 3/2 there. Again, there's this extra 10 if you want it. So just like this one, it was the exponent, wasn't it? Let's see that one more time. Make that an x. 10 raised to what power is 10 to the 3/2? Oh, just 3/2. So it turns out, that's our first property, it's called inverse properties, that if you have log 10 to some power, it's just n for all values of n. So even this one, that would be negative 4.5. Since, again, if I make this equal to x, this would be an imaginary 10 there. 10 raised to the x is equal to 10 to the negative 4.5, and you can see the x is equal to negative 4.5. It's true the other way around too. This is just going to be 1,000. Let's see that. Just so I can use this up here, I'm going to go backwards now. So I'm going to set this equal to x. So then I can say, okay, we can go now to logs, right? So this means log base 10 of the x, that's what we don't know, is equal to log of 1,000. And again, when there's nothing there, it means a 10. So that means x is just 1,000, right? So you can see here that it's just 1,000. So this is probably going to be 1. Let's try it. Make this an x. So there'd be log, going backwards, the base is 10. The x is what's in the inside, and the exponent is alone. And there's an imaginary 10 there, so the x is just 1. So here, the answer is probably just negative 10, isn't it? I have to think about that one. Let's try it. Let's set this equal to x, see if that's true. Log, the same thing, 10 of x equals log of negative 10. You'd think that works, but if you remember from the page before, log of negative 10 does not make sense, does not exist. So this does not work. There, x is no answer. The answer does not exist. The second property here goes over that. So if you have log 10, log of n is just the n, just like above, but you have to be careful with this one. This is for n bigger than 0, or for positive values of n is actually what they were thinking of there. If I read that. So that's what goes there. How do we graph these? Well, go ahead and fill out this table and plot those points. Go ahead, try that. Let's do the first one, y equals 10 to the x. We did that in the last section. Then you could do y equals log of x and check out what's different about it. Go ahead, try that. pause when you come back until you're ready to come back. Okay, here's the answers. To the first one, I got this by just plugging in my calculator, or you can do it by hand. That would be 10 to the negative 2, which is 1/100th, which means 0.01 tenths hundredths. You could do the same thing with negative 1. Plug in a 0, anything to the 0 power is 1. Plug in a 1, you get 10. Plug in a 2, you get 100. So what does that look like? Let's do the first one here. Y equals 10 to the x. So we have negative 2 is really small, very close to 0. This one's the same thing, but just maybe a little higher. 0 is 1, halfway in between there. 1 is 10. Oh my goodness, it goes up so high. 2 is 100. It's off the chart. I won't go ahead and graph that. That's what our exponential function looked like in chapter 6, in the last chapter. Logs, how does it differ? So if you haven't done this yet, go ahead and pause now and try it before you continue. Do the same thing. You can use your calculator for all these and then plot those points and see if you get the correct answer. Come back when you're ready. Okay, here's the answer. Simpler than you thought. If you just plug log, just get the first one, y equals log of 0.01. On your calculator, it's negative 2. Now, if you want to get this, I can actually put a 10 here. I could make it an x, but since it's already a y, that doesn't look like y, I'm going to say the base is 10, the exponent is y, is equal to 0.01, which means what? 1/100ths, which means 10 to the negative 2. So you can see that y is negative 2. You can do that for the next one and the next, or you can just use your calculator. Notice how these are switched, right? They're the opposites of each other, the inverses of each other. So you have here negative 2, it's 0.01, negative 1, 0.1, and it's flipped here. Right? 0 is 1, so it's 1 is 0, and so forth. So let's plot those. 0.01 is so close to 0, and it's about negative 2. 0.1 is a little bit to the right, but so slightly. 1 is 0. 10 is 1. And again, 102 is off my little graph here, so I won't worry about it. That's what that graph looks like. You can see it's the flip. It actually is, right, a mirror image of y equals x. So if this looks like this one looks like this, draw a line through here, you would see a mirror image with the line y equals x, because they are inverses of each other. So this is y equals 10 to the x. This is y equals log base 10 of x. Again, you can add that 10 there. So let's go ahead and do the exercise on the next page. Exercise 4. It says, take a peek at the next exercise because the purpose of this exercise is to figure out the rules in the next exercise. Evaluate each. You might need a calculator for a few of them. Actually, all of them can be done by hand, I think. But you should do most of them by hand. Try them by hand first. If you cannot, then you can go ahead and use a calculator, only if you need to. But try it by hand first. Try these. Pause. Come back when you are finished. So here is the answer. So if you remember from this, we just saw that property. This is 3 and this is 4. You can do this on the calculator if you're not sure, but that is 3 plus 4. Right? What exponent do I raise 10 to get this? Well, the exponent would just be 3. So this is going to be 7. If you do part B, I can figure this out first because we know law of exponents. You would, same base, you would add the exponents. So that's like really 7. So you can see here, this is also a 7. These are the same. If you go back down to exercise 2, which one does that look like? It actually looks like this one. One side is multiplication and the other side is addition. Let's make that smaller so we can see both at the same time there. Notice this side is multiplication, a times b, where this is log of a plus log of b. You're probably wondering right now why that is so. This is a very abstract concept, but it's because of the law of exponents. If you remember, logs are exponents, and we multiply two exponents together. What do you do to those exponents? You add them. Kind of weird. I will prove this to you when we get to the end of our videos, but for now, you just need to believe it by looking at this example. The next one. Notice C and D are not the same. This would be 3 times 4, which is 12. This one, you would have to do the inside first, so it'd be log of 11,000. If you just do that on your calculator, that one you do have to do on your calculator. That is 4.04, not the same as 12. So there's no property there. E and F. This one is just 5 minus 2 from the properties on the page before equals 3, because the log of 10 to an exponent is just the exponent. This one, I'm going to use the properties first and subtract here. Subtract those exponents, and so it's just 3. Those are the same. Oh, which one is that? Looks like it's division on the right, subtraction on the left. Believe it or not, it's that. Again, why is this? Logs are exponents, and when you divide two exponents with the same base, the base is 10, you end up subtracting the exponents. Very abstract. G and H. G and H are not the same. The left side, I just had to figure out the inside first and use my calculator. That one I have to use my calculator. This one, this is just a 5 over 2, but you can use your calculator if you need to. Notice how they're not the same. No property there. What about I and J? So this one, is not a 10, so I can't just bring down the 5. But I could say there's an imaginary base here. 10 to what power is 0.1 to the 5th. So that could be, you can use your calculator to figure that out. But just do the left side on your calculator. But I'm going to try it, attempt it by hand, because this is like to the 5th power. So, that's like saying 10 to negative 5. X is negative 5 is what you should have got if you plugged that in your calculator. What is this one? You can use your calculator, but I'll just attempt it by hand. There's an imaginary 10 there. I'm just going to figure out this one bit. So that would be 10 to what power is 0.1 or 1/10? That would be negative 1. So this would be X is negative 1. So that would be 5 times negative 1, which is also negative 5. They are the same. Which rule is that? There it is right there, that very last one. If you look at the top, we have the exponent. This one, it brings it out. The exponent makes it multiplication. Last one. For K, I just used my calculator. For I, we knew the inside was negative 1. I did that little note here. So I raised it to the 5th. Not the same. So those are the only 3 properties. The rest are not properties of logs. So let's go ahead and take our time to prove one of these. Let's prove the first one we did. So here's the proof. So I'm going to let X equal the first term on the right and Y to be the second term. And then I'm going to get them out of logs so we can think about it. So if you remember our rule, the base is 10, the exponent is alone equals A because of this up here, and we can do the same thing with B, 10 to the Y equals B. Now I'm going to multiply them. When I multiply A times B, I notice I can add those exponents. Now I can get it out of exponents by just going backwards with this. Log of 10, AB equals the exponent, and voila.